Hello. So let's take a little recap of what we did today now that my technology is working a little better. So we warmed up together with the Check for Understanding problem on Friday's notes, so 2.2, the very last part, almost to the end of your packet. So let's take a look at that question. When a professional golfer, Jordan Spieth, hits his driver, the distance of all travels can be modeled by a normal distribution with a mean of 304 yards and a standard deviation of 8 yards. On a specific hole, Jordan would need to hit the ball at least 290 yards to have a clear second shot that avoids a large group of trees. What percent of Spieth's drives travel at least 290 miles per hour? So a few things I want to zero in on here are the fact that I have a normal distribution and I am going at least 304 yards, or I have a mean of 304 yards and a standard deviation of 8 yards. So I'm going to draw that picture out just so I have it and label it. And I'm going to put 304 in the middle, and then we go about 3 standard deviations out on each side. So I can mark these if I want to. It's a little, you don't, as long as your sketch and shading is accurate, you don't have to label absolutely everything because this labeling takes care of a lot. So let's go ahead and mark out where 290 would be. So if I'm doing this question, 290, if I think about it, is going to be at least like a standard deviation down, right? Because this would be like 296. So I'm going to be a little further down. So maybe let's say about here. This would be about 290. And then it says we want him to go at least 290 yards. So basically 290 yards or more. So that's going to be my shaded part that I'm trying to find. So what I want to do is basically figure out where 290 would fall on the normal distribution, the standard normal distribution, so I can look it up, the correct area up off this chart. So if we draw the standard normal curve, so we can use our chart, just kind of showing where things are placed. Basically, this is all our z-scores. And so I'm going to say 290, shade greater than, but I need to find the z-score for this. So we're going to do z equals 290 minus 304, so data minus mean, divided by standard deviation, and that's going to give me a number of negative 1.75 for my z-score. So that's where I know on my picture I'm at negative 1.75. So then I need to look that up. So if I look at my chart, I'm going to go to negative 1.7, and I'm going to basically go over to the 0.5 row and get my area, which is 0.0401. So the area from the table equals 0.0401. Now, keeping in mind, I'm going to switch colors here. The 0.041 is that other side, because the table always gives us the areas to the left of whatever we're looking at. And in this case, we want the other side. We want the area to the right. So keep in mind the whole shebang, the whole picture here adds up to 100%. So we're going to have 1 minus 0.0401, which is going to give us about 0.96. So we would say 96% of drives by Spieth will be at least 290. Running out of room. So that's just a warm-up problem we did together. One we didn't quite do together because my technology was being difficult, was this one, but I'll go over it now. So let's take a peek. The second question is asking us what distance would Spieth have to drive the ball to be in the top 10% of all of his drives ever. So let's draw a picture. So 304 is the middle here, and we want the top 10%. So we have this area we know is 10% or 0.10, and we want to label this again. And basically we need to know this location, and and like, what is that number? What is that drive length in yards that would put him in the top 10% of all of his drives. So we're basically working backwards. So what I want to do, or what I want to remember, is I want to go to my chart. Remember, the chart gives us this side. So basically, if the side I'm looking for, I know there's 10% up there, that means there's 90% down here. So I'm going to go to my chart and find basically the closest z-score I can to 90%, which in this case is the closest one is going to be this guy here, because these are both like close to 0.9, but the 0.8897 is closer. So I'm going to take that z-score, which is 1.28. So now I'm going to do some algebra and basically just work backwards. Let me show where my z-score is placed here. So 1.28. And now we're going to just do some algebra to find what value we would need to get 1.28 in this distribution. So we have our value minus 304 divided by 8. So if I multiply both sides by 8, so I'm going to multiply by 8 on both sides. I'm going to get a number. Use my calculator here quick. So I get 10.24 equals x minus 304. If I add 304 to both sides, x equals about 314.24 yards. So basically what we can say is a drive of 314.24 yards will be in the top 10% of all drives by species. And that's kind of the working backwards example. So then what we did is we broke into groups and did a couple questions for a scenario here of Mrs. Fitzgerald totaling her car and having to drive a Mustang. And so we're pretending that I went to a raceway and took 400 laps in my Mustang that I had to rent for a week after I totaled my car. But it is, of course, going to follow a normal distribution, and we have a mean of 1.84 minutes and a standard deviation of 0.07 minutes. So we went through and did some group questions, and we did number one. We had two different groups kind of examine this one, a between situation. So making sure we're going through and understanding how to find an area between instead of just like greater than, less than. So on this question, I would say both groups did pretty all right. In terms of, we do have work for at least one of the z-scores here. I would note a couple things when I'm looking at this, just to make sure we understand for tomorrow's quiz. A few good things to note is we've got a z-score for both of our pieces of work, which is good. On this group, we only see it once. So make sure you show the work for the z-score for each one. So you're finding the z-score for 1.85 minutes and 1.75 minutes. And then we just want to make sure we also have both pictures shaded appropriately. So this one shows us like our z-scores, essentially that version of the picture. And this shows us with context. So we do have the context here. We just want to slap a label on this one to make sure, run out of room there. So this is going to be, we want to slap our label here to make sure that's complete. Then as far as the rest of the work, we can see z-scores here. We just need a formula on this one. This group, the only thing I would add is just saying these are the areas from the table. Same thing down here when we're doing that math. So the only thing that we want to make sure we have, and my picture might have gotten cut off, is the final answer on this one. So just making sure you're boxing in your final answer with the appropriate number at the end. That's a good habit to get into for the AP exam, so people don't have to search for your work. Question 2, I'm going to post the key for, so you can take a peek at that one if you want to practice. We didn't have a group work on that one. We did have a group work on this one. So a few things that we would want to note to make sure that we understand, to make sure we have all the parts. So picture looks good here. We've got a good shaded part for our work. We want to look at more than 2 minutes. So the only thing I would remind you of is just make sure we've got a label on this. And then we want to show obviously some work for this one. So we want to make sure we've got the Z-score numbers like shown with what we get. And then obviously the area that we pull from the table. And in this case, we would have to, the area that we find, since we're going greater than, we would have to do 1 minus whatever we find from the table, because we're doing the other direction, the right side direction, instead of like the less than or left side like the table will get. So great job setting up the picture, and we just need to show a little more work to get this number and show how we got that number. Now on number 4, I have 2 attempts here. Number 4 is a little trickier. So it's a working backwards one. But what we want to think about is the context of the problem. So this one, it says Mrs. Fitzgerald has to be in the top 3% of all lap times. So if you originally look at my work, I just kind of went, all right, cool, top 3%, that's at the top of the curve, right? But thinking of lap time, so thinking of being in a race, if I look at my answer here for my work, working backwards, I looked up this Z-score in the table. I found my area, like my area to the left here was like 0.97, yada, yada. I found that in the body of my table and found the Z-score that went with it. But does this lap time look like it would put me in the top 3%? That's 2 minutes. It's almost 2 minutes. That's slow. So we want to think about that. So on this one, we had a couple people give us some thoughts here. Basically, we want to think about what it means to be the fastest. So in this question, we want to think about faster times mean lower times. So the top 3% of times are like those like times that are the quickest, meaning in this context, your top 3% is actually down here, because that would be where the lower times are. So it's basically a symmetric curve. So if I go and look up on the table, find in the body of the table all the numbers, and I find the closest to 0.03, that's going to be a Z-score of negative 1.88. And then I just work backwards with my algebra to get this lap time. So a lap time of 1.71 is going to put me in the top 3%. And in terms of racing in a context, that sounds a little better than almost a 2-minute lap time. To be in the top 3%, you want to have quick times. So a time of 1.71 would be better. So the biggest thing for the quiz tomorrow is to make sure you got both pictures, show any work, and then obviously zero in on your final answer. Work being numbers plugged into the Z-score formula, making sure you find areas and write those out from the table, make sure you're showing that clearly, and then circling or identifying with written context your final answer.